Hello everyone, and thank you for coming to the tool demo for FlakeSync, a tool for repairing asynchronous flaky tests, presented by myself, Nandita Jayanthi, Shanto Rahman, and Dr. August Shi at the University of Texas at Austin. The issue of flaky tests in asynchronous execution is quite common due to the non-deterministic nature. In the example shown here, test gRPC executor pool needs to wait on
line 10 in gRPC thread pool executor
to finish processing, and it allows 120 milliseconds to wait. setGauge increments some values that the test asserts later on. However, if the task is not finished in that time, the values will not be updated. This makes setGauge the critical point because if the test does not wait adequately, it will fail. Ideally, there will be some barrier point in the test code that waits until this critical point is finished. In this example, the barrier point is right before the test calls getGaugeMap, because the correct value needs to be updated by that line in order for the test to pass. This causes the test to be categorized as flaky. To solve this, we propose a technique for automatically repairing these flaky tests by identifying the critical point and barrier point and patching the classes with synchronization between the 2 points. The critical point is the point at which, if a delay is inserted, the test will definitely fail. This is because the test relies on the necessary computation being completed by this point, allowing for the test to proceed without failing. The barrier point, on the other hand, is the line that must wait for the critical point to finish executing, synchronizing with the critical point so that the test can pass. This is why we insert a while loop for the critical point to execute an adequate number of times. Lastly, the plugin generates patch files for both classes, the class containing the critical point and the class containing the barrier point. We have packaged this tool as a Maven plugin. The Maven plugin consists of 6 goals that communicate with input and output files. Now I will walk through a demo of the FlakeSync tool. Starting in the root of the project repo, we will build the Maven project, getting it ready for our tool. Our first step is running concurrent method finder. This generates a list of all concurrent methods that will be used as input to the next phase, delay injector. Here is the list of all concurrent methods. Delay injector adds delays at all locations in viable current methods. It generates a maximal list of all locations that may cause test failures if delays are added. The smallest delay time to cause a test failure is chosen. This outputs a file, locations.txt. As you can see, locations.txt has many such locations. This file is input for Delta Debugger, which whittles the list down to minimize list of locations. The final output should be locations-minimize.txt, which contains the smallest list of locations where delays may be added to induce a test failure. In this case, that number of locations is 1, and we have one final location. Crit search takes this location and runs root method and critical point search, putting together a list of root methods that may contain critical points. Using this, it then generates the list of critical points by iterating over each root method. Here is the criticalpoints.csv file that contains the list of critical points after this goal is executed. Based on each critical point, barrier point search analyzes the stack trace of each corresponding failure to narrow down all the barrier points. This forms at least one pair of critical point barrier point pairs, and these are shown in barrierpoints.csv. This list of barrier points is fed into Patcher, which applies synchronization to the critical points and barrier points as seen here. Here you can see the patch file for the critical point class, and here you can see the patch file for the class that contains the barrier point. As you can see, a while loop has been added, which waits for the critical point to execute the required number of times, as given by the threshold. In conclusion, we created a tool to repair flaky asynchronous tests, and feel free to reach out with any questions or concerns. Thank you for listening.